Hello everyone and a very good day. For our business statistic assignment, we chose monthly landings of marine fish by state. An analytical study in business statistics using real-world Malaysian fisheries open data. Study overview and the source data. Why fish landing data? Fish landings shows the physical amount of seafood brought to ports after fishing cycles. This is a critical metric for monitoring ecological sustainability and local food supply health in Malaysia. The core objective of this assignment is perform comprehensive group and ungrouped statistically calculations. Also, we extract underlying trends using modern visual dashboards such as histogram and also OGIF. Team task and project timeline. We divided the task fairly among members. For introduction, it's done by me. Core data done by Shami. Frequency table done by Nadira. Math analytic done by Wani and Shami. Data visualization done by Seri Myra. And for conclusion, done by Kaira Miacinta. And for the operational milestones, progress tracking and also consultation schedule, we track all of our assignment due date and also the progress frequently, and we don't want someone fall behind. And for the framework, we follow the guideline as well as Madam Fazrina said, and we stick with the rules.
As you can see on the slide, our research collected a total of 24 daily observations, measured in metric tons. To ensure our calculations are straightforward and error-free, we have pre-arranged these 24 data points in ascending order. Let's look at our dataset profile. Our lowest recorded landing or minimum value stands at 80,422 MT. Our highest record, the maximum value, reaches 127,996 MT. This gives us a total data range, the spread between our maximum and minimum values of 47,574 metric tons. Having this sorted baseline profile allows us to seamlessly move into constructing our statistical models without manual layout bias. Moving on to our methodology. Let's look at how we structured this raw data into a clean frequency table. If you refer to this slide, we broke this down into two core technical steps. The first step is calculating the number of classes. To ensure completely objective layout divisions, we utilize the standard log formula equivalent to Strugger's rule. K equal to log 10 in bracket n over log 10 in bracket 2. It's equal to 1.3802 over 0.3010. It equals to 4.585. Rounding this up gives us an optimal target of 5 class division. Next, move to step 2, determining our class size. We find our class wide by dividing the total dispersion spread by our class count variable. So, C equal to maximum minus minimum over K. So, it equals to 127,996 minus 80,422 over 5. So, it equals to 9,514.8. To keep our data presentation neat and statistically sound, the finalized clean weight of each class is rounded up to 9,515 units. So, finally, let's look at the culmination of our methodology. The completed frequency analysis shown here in this slide by applying our calculated class weight of 9,515, we assembled 5 distinct class intervals alongside their respective precise class boundaries. Here are the key takeaways from our structured frequency model where our total sample size equals 24. Our highest concentration of data falls within 108,967 to 118,481 MT interval. With a frequency of 9, this stands out as our model class. The cumulative frequency steadily builds up across the brackets, accurately accounting for all 24 observations by the final interval. We've also calculated the midpoints for each group, which allow us to determine the vital product columns needed for advancing modeling. Our total F times X equals to 2,586,651, and our total square variance sum comes out to 282,550,000,000 and 336,899. These structured values provide the core foundation we need to calculate deeper descriptive statistics, such as the mean, variance, and standard deviation of our April fish landings.
For the measures of central tendency, we calculated the group mean, median, and mode. The mean is approximately 107,777.13 MT, which represents the average fish landing value. The median is 111,080.94 MT, showing the middle point of the group data. The mode is 114,675.5 MT, which shows the most common landing value based on the model class. Since the mean is lower than the median and mode, the distribution is slightly left skewed. For dispersion, we calculated the range quartiles into quartile range and quartile deviation. The range based on midpoint is 38060 MT. The first quartile, Q1, is 97072.75 MT, while the third quartile, Q3, is 117,424.28 MT.
The interquartile range is 20,351.53 metric tons, which show the spread of the middle 50% of the data. The quartile division is 10,175.77 metric tons, which show the typical variation around the middle section of the data. Measure of depression. This slide focuses on variance and standard deviation. The population variance is 157,022,030.86, which show us how much the fish landing values vary around the mean. The standard deviation is 12,530.84 metric tons. This value is relatively small compared to total scale of the data, which suggests that the fish landing are quite stable overall.
This histogram shows the distributions of fish landings. The class interval 108,967 to 118,481 MT has the highest frequency with 9 months or 37.5%. Therefore, it is the model class and the most common landing range. This all shows the cumulative frequency of fish landings. The graph rises steadily with the biggest increase occurring between 108,966.5 and 118,481.5. This confirms that most observations are concentrated in the model class.
Last but not least, the conclusions and reflections. Through systematic statistics, we mapped raw marine landings data into actionable insights, showing stable supply structures across major Malaysian ports. The academic value is that we constructed and validated core business statistics formulas for grouped calculations, learned how open data resources support predictive economic modeling, and collaborative successful team delegation allowed us to complete timelines seamlessly, matching administrative requirements set by UniKL Business School.